So if we have a polynomial of the 8th degree in x, so this is P8 in x, we need 8 different solutions. So for these 8 different solutions, the first one that might come to mind is 1, because 1 to the power 8 is 1. This is almost trivial. Another solution is -1, because -1 to the power 8 is also 1. Okay, it's easy for us to pick it up. Another solution, which could be intuitive, is I, which we know that I, if we take I squared, this is -1. I to the power 4, this is 1. Okay, and I to the power 8, this is 1. So this is satisfied. Similarly, -I squared, this is equal to -1. So let's separate this like this. Then -I to the power 4, this is, we take this to the square, so this is 1. And then we say that -I to the power 8, this is 1 again. So we found 4 solutions so far. Then where are the other solutions? And let's think about the complex number as such. So here we have a two-dimensional coordinate system, which looks like the Cartesian coordinate system. But this is the complex numbers representation, where this is the real part, which would be here 1. This is going to be the complex part. Here we have the real part. So the horizontal axis, this is the real part projection of the complex numbers. And the vertical axis, this is the projection of the complex part of the complex numbers. So far, these 4 solutions that we have here, they are shown here like 1. Here, this is -1. Here, we have the I, the square root of -1. And here, we have the -I. For the sake of having an 8th order polynomial, we need 4 more solutions. And these 4 more solutions, the way to write those would be the following, which is that this one, x to the power 8, this is equal to 1. This is in fact e to the power j times 2 pi times n, okay? Because here, 1 is equal to e to the power j or I. So j or I is, so actually, let's write this from I better. This is I times 2 pi times n, okay? Where n is equal to 0, 1, 2, 3, etc. So if n is equal to 0, e to the power 0 is 1. If n is equal to 1, we have e to the power I times 2 pi times 1, which is e to the power I times 2 pi, which means that we start here, we move across a circle with a radius equal to 1, and we end up at 1 again, like here. But if we rotate the axis by an angle of pi over 2, we have e to the power I times pi over 2. What this is, if we rotate by an angle of pi over 2, we end up at I, okay? So this is I. If we rotate by an angle of -pi over 2, we come down to this other angle. So this is equal to -I, okay? But then, so this is I to the power -pi over 2. It looks like, wait a second. And there is also an identity which can help us to understand this, which is the Euler identity. But let's not talk about it yet. Let's only assume that 1 is represented like this. Then, given this expression, we can take the √8 of this expression. So we can get that x is equal to, this is x to the power 8, all to the power 1 over 8, which makes this equal e to the power I times 2 pi n divided by 8, okay? So this would be the correct answer, which means that x is equal to e to the power I times pi over 4 times n. Okay, so it looks like n is going to be equal to So n is equal to 0, 1, 2, 3, and so on. So then this means that for n equal to 0, we get 1. We found the solution. That's good. For n equal to 1, this means that we are going to rotate in the complex number domain by an angle of 45 degrees, because this is, so we end up right here, okay? So we rotate by 45 degrees. This is n equal to 1. For n equal to 2, we rotate by the angle by 90 degrees, so we get here. We already had the solution, which was I. For n equal to 3, so this is n equal to 3, we get this solution. For n equal to 4, we end up here, which was this number. N equal to 5, we get this solution. N equal to 6, we already knew this solution. N equal to 7, what is n equal to 7? It's e to the power I times pi, sorry, this is pi over 4 times 7. So this means that we are going to rotate by 45 degrees 7 times. Here we have 1, 2, 3, 4, 5, 6, 7. So this is n equal to 7. And n equal to 8, we come back here. So if we count correctly, we can get 8 different roots. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 roots of a polynomial x to the power 8 equal to 1.